So today we're going to be doing some Maple worksheets and learning how to do limits and derivatives on Maple. So to make your Maple look like mine, you're going to go to Tools and Options. And then when you're here, you're going to go to Display, and you're going to make sure this says Maple Notation and this says 2D Math. And then if you go to Interface, make sure that it says Worksheet. And then you apply globally, and it will go to it every time you go on. So we're going to start off with typing with student. What this does is it allows Maple to know that we're using one of these things right here, and it will allow for different commands such as the derivative and limit command. Or if you're just wanting the calculus commands, what you could do is you use a square bracket, type in capital C calculus 1, end of the square bracket, and that'll tell you what every single calculus command is. To start, what we're going to do is we're going to just type any expression. So in Maple, what you need to do is you need to type a letter, excluding D, and then have a double dot and the equal sign before naming any variables. So let's say for this, we're going to use x squared as our expression. You have the double dot, and we're going to use the expression x to the power of 2. So to the power of is going to be the hat symbol. So after this, what we're going to do is we're going to try to find the limit. So what we'll do is we'll write limit, and then since we're using the variable f, we're going to type f, and x equals, and then we're going to put a. A is just any number that you want, and it'll tell you the limit as it goes to that point. So it'll say a squared here, but if we say we want to know what 2 is, the limit of f as x is approaching 2 will be 4. Then what you can do is have the limit as x goes to infinity. Make sure you have this at the end, or else it won't work. And when you press equals, it'll show you that it goes to infinity as well. And then what you can also do is have the limit as of f as x equals, and you'll put, let's say we'll have a for right now, and then we'll try something soon, and we'll say we want to go from the right side. So let's say we want to go from 4 just from the right side. It'll give us 16. And then you can also have limit as x approaches some variable from the left side, and that will give us it from the left. So 4 will also give us 16 because it goes to the same point. Finally, what you can do with a graph is you can plot it. So you'll type plot f, open bracket, f of x is equal to, and now here's, you're going to type some number is where you want to start the graph, and you're going to do a double period, and then you're going to put a number where you want the graph to end. And make sure you put a semicolon at the end, and it'll give you your graph from -4 to 4. You can change this to make it -9 to 4, or you can make it 0 to 4D. Doesn't really matter. It will always graph it. So we're going to do a couple exercises. The first exercise, we're going to call it G. So that because we already used f earlier. So what we're going to do is we're going to have g is equal to sine of x divided by x. Make sure to put the semicolon and enter. So this is what our equation is going to be for this time. We're just going to do the same steps as before. So we're going to start off with the limit of x. We're going to put g as x approaches 0 and equals 1. So now what we're going to do is we're going to plot it, and we're going to have it from x, but since we're going to use sine, we're going to use pi. So we're going to put negative. So if you want to use pi in Maple, it's capital P I, and then we're going to go negative pi to positive pi, and that'll give us our graph. And then we'll do the same thing, plot g from x equals, we're going to put negative capital P pi, double period, this pi, we're going to make it both of them divided by 2. Now we're going to change it up a little bit. We're going to have the color equaling red, and we're going to change the thickness of the line be equal to 4. Semicolon, enter. You can see that the line is a lot thicker and a different color. Okay, question number 2 is going to be, we're going to say h is going to be x multiplied by sine of 1 over x. So if you didn't know, when you're using code or Maple, the multiplication is going to be the asterisk symbol, and we're going to use the semicolon at the end. So we're going to do the same steps as before. We're going to find the limit of h as x approaches 0, and we'll see that it's 0. For this one, we'll say the limit as h as x approaches infinity, and we'll see that it equals 1. Now, what we're going to do is we're going to plot the graph of h as, we'll say, x is equal to negative capital P pi, double period, to capital P pi. And we'll get the graph. And then, just for a little bit of fun, we're going to change the color to blue, and we're going to change the thickness to 6. Question 3 is going to be x squared minus 1 divided by x plus 1. So what we're going to do is just the same steps as before. We're going to find the limit as limit of j as x is approaching 0, and we'll find the limit as j of j as x is approaching infinity. Then we're just going to plot it, j, and since it's just x's and no signs, we're going to just use regular numbers. So we're going to put plotting it as x is equal to negative 10 to 10. And then we'll try it with 1,000 to 1,000. And we'll see it's just a straight line. Next up, we're going to do derivatives. So I used with student again. And we're going to start off with just a simple derivative of cos of x, a semicolon. So then all you gotta do is put diff, and then f, and then whatever variable you want it to be derived by. So in this question, we only have x, so we want to use the derivative of x just to get us negative sine of x. So next question we're going to do is, we're going to call it g as colon equals, we're going to put one large bracket, we're going to have x squared minus 2 multiplied by x. So instead of writing 2x, you have to write 2 multiplied by x, or else it won't work. And then plus 6. And then we're going to divide that by x minus 3. And all the brackets work, so semicolon, enter. Now what we're going to do is we're going to have to find the diff of g with respect to x. So we can find the derivative nice and easy right there. Now we'll solve the second derivative by naming this as h. And now all we have to do is put the diff of h in terms of x. And now we've found the second derivative as well. Our final example, we're going to call it j, and we're going to have x squared minus 3 multiplied by x plus 2. Will give us that. Now find the derivative of j with respect to x. And so now to find the critical points, what we're going to do is we're going to type solve. We're going to put our equation from right here. And then we're going to make it equal 0 because we want to find when it is equal to 0. Have it, comma, x. And that will give us our critical points being 1 and 2.